Okay friends, so today I'm going to explain the pigeonhole principle. So pigeonhole principle. So what is a pigeonhole principle? So suppose you have, let's say you have pigeons, you have 4 pigeons. Okay, you have pigeon 1, pigeon 2, pigeon 3 and pigeon 4, and you have only 3 holes. So you have hole 1, you have hole 2 and hole 3. Okay, so now what happens is, so pigeon number 1, it goes to hole 1, pigeon number 2, it goes to hole 2, pigeon number 3 goes to hole 3, but then we are left this with one extra pigeon number 4, and all holes are filled, so it has to go to one of this hole, h1, h2 or h3. So what happens is there will be at least one hole with 2 pigeons in it. So there will be at least one hole with 2 pigeons in it. So what is the pigeonhole principle? So the principle is, suppose, let's say if we have m items, the items are nothing but the pigeons. So if we have m items and n containers, the containers are nothing but the holes. Okay, where m is greater than n, so the pigeons are more than the holes, then by the pigeonhole principle there will be at least one container or the one hole with at least 2 pigeon. So then there will be one container with at least two pigeons. So what is the ceiling? So it's a ceiling of m divided by n. So if our m is 4, so we have 4 pigeons and our containers are 3, so we have only 3 holes, then there will be at least one container with 2 pigeons. So we'll take ceiling of 4 divided by 3. What is the ceiling of 4 divided by 3? So that will be ceiling of 1.333, and that will be equal to 2, right? So that is a pigeonhole principle. Now let's take one example. Okay, suppose, let's say we have n people. Okay, we have n people, then there will be at least two people who have same number of friends. Okay, so let's solve this by the pigeonhole principle. Okay, so we have n people. Okay, let's take that n is equal to 4. Okay, so we have 4 people. Okay, and then let's take one example. So people number 1, he is friend with people number 2, and he's friend with people number 4, right? And people number 2, he is friend with people number 1, and people number 3, the person 3, he is friend with person 4, right? And person 4, right, he is friend with 1 and 3. So if you count this, right, this has 2 friends, person 2 has 1 friend, and person 3 has 1 friend, and person 4 has 2 friends. Okay, So 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 what we have now is, so if we have n is equal to 4, then one person can be friend with maximum of n minus 1 other person. So if we have n is equal to 4, then person number 1, right, the person number 1 can be friend with maximum of only 3 other person, right? So he can be friend with maximum 3 other person, right? So by the pigeonhole principle, right, so let's see, so we are saying that there will be at least 2 people who will have same number of friends. So let's do this. Let's say the person number 1, okay, he is friend with n minus 1 people. He's friend with n minus 1 people. So he's friend, person number 1 is, in our case, the person number 1, he's friend with 3 other people, 3 other person. Let's say person number 2, he is friend with n minus 2. So he is friend with 2 other person, okay, he is friend with 2 other person. Person number 3, okay, he is friend with 1 other person, right? And person number 4, now for this one, right, so maximum we can have n, the person can be friend with n minus 1. So maximum you can have, you can be friend with only 3 people. So the maximum number of friends you can have is either 1, 2 or 3, right? Now for the 4, right, the person number 4, right, he has to be friend, so the number of friends, person number 4 has to be out of this 1, 2 or 3, right? So he can either have 1 friend, 2 friend or 3 friend, but it has to be out of this 3 option, either 1, 2 or 3, because you can have maximum n minus 1 friends. So person number 4 has to have friendship with 1 person, 2 person or 3 person, not more than that. So let's assume he's friend with 2 people, or maybe 1 or maybe 3, right? Any number we choose, right, we can choose 2, 1 or 3. Any number we choose will have at least 2 people who have same number of friends, right? So by the pigeonhole principle, what is our container here, right? Our container is, so we have n are the number of people, which is 4, and how many containers we have? We have n minus 1 container, so we have n items, we have 4 items, and we have n minus 1 container. So by the pigeonhole principle, right, what is the pigeonhole principle? We'll have at least 1 container with a ceiling, right, with a ceiling of n divided by n minus 1, right? So we have 4 items and 3 containers, so we'll have at least 1 container with 2, we'll have at least 2 people with same number of friends, right? So that is a pigeonhole principle. Let's take another example. So the another example is, suppose we are given numbers 1 to 20, okay, 1, 2, 3 up to 20, okay, and I'm saying that you need to pick 11 numbers, and out of the 11 numbers that you have picked, the sum of at least 2 numbers is equal to 21. So you have to prove this by pigeonhole principle, right? So I'm saying that you are given 1 to 20, you need to pick 11 numbers, and if you pick 11 numbers, there will be 2 numbers in those 11 numbers whose sum will be equal to 21. Okay, so let's make a set. Okay, so which 2 numbers make 21? 1 and 20, it makes 21. Okay, 2 and 19 makes 21. 3 and 18 makes 21. 4 and 17 makes 21. 5 and 16 makes 21. 6 and 15, sorry, 6 and 15. 6 and 15 makes 21. 7 and 14 makes 21. 8 and 13 makes 21. 9 and 12 makes 21. 10 and 11 makes 21. So now I need to pick 11 numbers. Okay, so let's say from this set I'm picking 1, from this set I'm picking 2, from this set I'm picking 3, and I know the numbers I have picked so far, it's not gonna add up to 21. Any combination will not add up to 21. So from this set I'm picking 4, from this set I'm picking 5, from this set I'm picking 6, 7, 8, 9, 10. So now I need to pick 11 numbers. So I need to pick one more number. Now any number that I pick, right? If I pick 11, then I know 11 and 10 will make 21. If I pick 12, I know 12 and 9 will make 21. If I pick 13, it will make 21. 14 and 7 will make 21. So any number I pick now, the 11th number, no matter what number I pick, it will make 21. If I pick 17, then I know 17 and 4. 17 and 4 will make 21. So it's gonna make 21. There is no way I can avoid it. So what is a container here? Okay, so we have how many items we have? How many items? We have n is equal to 11 items, and the container, right? Our container is only 10. We have 10 containers, right? We have this 11 items. We need to pick 11 numbers, and we have only 10 containers to pick from, right? So no matter what you will do, you will end up with 21. So it's a ceiling of 11 divided by 10, right? So there will be two numbers, so sum will be equal to 21. Let's look at one more problem. Okay, so suppose you are given a square. Okay, you are given a square. Let's see, let's make a square here. So let's do this. Let me, sorry. Okay, suppose you are given one square. Okay, so let's do it here. Okay, so suppose you are given a square. You are given a square, and let's see, you're given a 4 by 4 square. Okay, okay, and you are given 17 dots. You are given 17 dots. Okay, and the question is, there will be at least 2 dots which will be near to each other, and their distance will be, the distance between those 2 dots will be less than equal to square root of, let's say, two. Okay, so let's see. So let's assume that the square, right, it's 1 centimeter. Okay, 1 centimeter square. Okay, now we are given 17 dots, so we'll have 1 dot in the square. Let me change color. Okay, let me change color. Okay. So we have one dot in this square, we have one dot in this square, one dot in this square, one dot in this square, one in this. Okay, so we have 16 dots and 16 squares, so we have 16 dots and 16 square. Now there is this one dot left. Okay, so if I place that one dot, for example, let's see if we have this dot in the first square at the very edge, somewhere here. This dot is here. Okay, here, and this dot is here. Okay, now if I place one dot here, right, I can place it here or I can place it here, right? There will be one square which will have two dots, right? So what happens is, if you measure this distance, the diagonal distance, right, this diagonal distance of the square, right, so what is it? It's a square root of 1 square plus 1 square, which is equal to square root of 2, right? So the points, right, the 2 points, right, there will be one square which will have 2 points, and that 2 points will be in the proximity. The distance between those 2 points will be less than or equal to square root of 2. It will be this, right? So this is one way of giving problem. Or you can they can also give you a problem like this, that you are given a square, suppose this is 2, right, instead of 1. This is 2, right? So what will be the diagonal? It is 2 square plus 2 square, which will be 8, right? So 2 points will be, and the distance between the 2 points will be less than equal to 8. So you can also change the problem, and instead of doing like this, they can just give you that you are given an 8 by 8 square, and you need to prove that you have a 2 dots with less than equal to square root of 8 distance between them. And what is the maximum number of dots? What is our n? You are asked to find this. That would be 17, right? So again, this is the same pigeonhole principle here. Thank you so much for watching the video.